Now we come across the third law. Now by definition, if we look at the third law, we see that the definition says to every action there is always an equal and opposite reaction. There is always an equal and opposite reaction. So if we try to understand this with a real life example, say suppose you have been given a huge box of mass m which is placed in a floor. Now sometimes it is difficult to visualize, but the box m is putting a force of mg. This is putting a force of mg. Now m is the mass and g is the acceleration due to gravity. Now we have already discussed that force is equal to mass into acceleration. This is force equals to mass into acceleration. So mass m and acceleration. Now what is this acceleration? If you are placing any object in earth. Now earth has a gravitational acceleration of, this has a gravitational acceleration of g. G is your gravitational acceleration. So this g is due to the gravity of earth. So any object in this earth, in this surface, will have a g acceleration, and the force that is given by that object is equal to F equals to mass, where your mass can be anything and g. So coming back to the example, this box applies a force of mg. This box applies a force of mg. Now it is strange to think that the earth, that is the ground surface, also is applying the same force. It's also applying the same force mg upward. If the box is applying a force downward, the surface will also experience or also apply a force of mg upward to this box. Now it may sound strange. Now let's look at another example which will justify this particular definition. Just take a rubber sheet. Take a rubber sheet and place a heavy ball. So what you will see is that this sheet has a slight downward motion. If you place a heavy ball over here, this ball m, if you place it over here, you'll have that the ball g is going inside this rubber sheet. This ball is going inside this rubber sheet, and if we look at the rubber sheet downward, we'll see that it has a bulge. Why is this so? Because the ball is applying a force over here, applying in this sheet, and it's going down. The rubber sheet is going down, and this rubber sheet in turn is applying a force mg. Now taking this example further, now the extended part, now if you hold the extended part and you replace the heavy ball m with a lighter ball, say small m, a very small m, then if you release this particular extended part, you will see that this rubber sheet throws away this particular ball. This rubber sheet throws away the small ball m away from each. Throws the small ball away from the sheet. Now why is this so? The force that is applied by the small ball m is just mg, which is very small as compared to what the huge ball mg was giving. So the sheet was also giving a force of mg to the big ball m. But as soon as we hold the sheet and we replace this with a small ball m, the force becomes unequal. Say this is small mg over this point, and the force applied is big mg. So there is a difference in force. So the net force is in the upward direction, and that is the reason why the small ball gets thrown away from this sheet. Now with this particular example, we can understand what is the third law. The third law by definition says that to every action there is always an equal and an opposite reaction. That is, if you apply a force in a particular object, the object also applies the force in the same direction. Now if the force is greater, sometimes this particular force goes into this particular force travels in the direction of the bigger force. If this is F1 and this is F2, F1 minus F2 will be their respective direction of force.